The standard xy coordinate plane below, point A has coordinates 2, -4. So that's just saying what we see is true, and B is -8, 1. Divides AC so that the ratio of A to B, B to C is 1/3. What are the coordinates of BC? Okay, this is tricky. So let's first figure out the distance here. So you can do this either the distance formula or you can do Pythagorean theorem. So let's just do Pythagorean theorem. This is 3. This is 6, right? 8 minus 2 is 6. So 3 squared plus 6 squared equals c squared. So 9 plus 36, 45 equals c squared. Square root of 45, that means c is about 6.7. So this length is 6.7. So if we know a to b to b to c, a to b to b to c is 1 to 3. So if this is 6.7, this can b to c, it's going to be 3 times that. 3 times 6.7 is 20.1. So now we know that whatever length b to c is, let's put that in red. So b to whatever c is, wherever direction that goes, right, has to be 20.1. So now we can use the same concept to figure out which one of these coordinates will give us a length of 20.1. And this is where knowing the distance formula will actually save a lot of time. So let's write that down. So the distance formula is really just a manipulation of the Pythagorean theorem. C squared equals a squared plus b squared, so c equals square root of a squared plus b squared, which is really all we're saying the distance formula is. So now you can plug these coordinates in to the answers to see which one is going to give you the 3-to-1 ratio, or the 1-to-3 ratio, or 20.1. So I'm going to go with kind of my gut instinct and say, these look too small, right? If I'm looking for a line that is 20.1, then it needs to be really over 20 between the x coordinates. It's not necessary because the y coordinate could change that too, right? So if you have a line, it could change where the line is. This one looks like might be too big. So I'm going to actually start with choice D and plug that in and see what happens. So let's just plug in our x2 and x1, or y2 and y1. So we're going to have 26, right, this number here, minus 8 squared plus, now let's do our y coordinates, 8 minus -1 squared. We're going to take the square root of all of that, and we're going to see, does that equal 20.1? So we get 18 squared plus 9 squared. So 18 squared is 324. 9 squared is 81. So those added together are 405. And then we want to take the square root of 405. And that does equal 20.1. So that's our answer. So D. Now, if that had not been the answer, I would have had to check the others. My second choice to check probably would have been choice A, because B would definitely be too small, right? And so we know we can eliminate B. And C looks too small. The reason why I check B, that -13 gives me some hope there. But we got the answer in D. So it's a little bit of a tricky question. And it definitely helps if you know the distance formula, so you don't have to just draw a bunch of triangles. So D. Each post has a 3-inch radius. What is the length to the nearest inch of the shortest wire that will go around the 4 posts? So we want to know really what's the perimeter as it hugs the wires. So if it has a radius of 3, that means that's another 3 and another 3 and another 3. So from one side to the other is 12. So all the way around, if we don't cut the corners, is going to be 48, right? So we know it's definitely not 52, and pretty sure it's bigger than 33. So if I'm going quickly, I'm just going to guess and say J, right? We can figure this out. Let's go through how we figure it out. So if we want to calculate it precisely, which I probably would not do on the ACT, the circumference formula is 2 pi r. So 2 pi 3 is the circumference. And we want to divide that by 4 because we don't want the whole circumference. We just want a fourth of the circumference of each one of these, this little spot right there. So 2 pi 3 divided by 4 equals about 4.7. And so if we're just getting the corners of each one, right? So just the corners. So from here to here is 4.7 on each of those. So 4.7 times 4, if you will. And then the rest of it from here, from the middle section, here to here, and here to here, we know is 6. 6, 6, 6, 6. So that's going to be plus 6 times 4. And that equals, you add those two together, and it equals 42.8. Put that in red. 42.8. So if you wanted to be precise, you could. I would just ballpark it and make this one quick. To me, that's a super fast answer because you know it's bigger than 33 and smaller than 52. So a 15-second question that's a number 52. Okay, this is really a concept question. So you have to know I is an irrational number, imaginary number, right? So what this is really asking, the product of 3 plus bi and which of these expressions must be a rational number. What it's really saying is which one will get rid of I, which one will eliminate I. So if we did, if you just kind of think your basic algebra, 3 minus bi, 3 plus bi, and you just FOIL those out. You get 9 plus 3bi minus 3bi minus bi squared, right? Now you have 9 minus bi squared. Well, if you know I squared equals -1. So now we have, that one will get rid of I altogether. So b minus b -1 squared. So e. You could also put this in your calculator to see which one would work. So just put a number in for b and that would work. For positive integers x and y, where x is less than 8, log base x 8 equals y. You could plug these numbers into your calculator and see what log base what x 8 equals y. So it's an integer, it's a whole number, right? So I usually use this as my example. So log b to the n equals x means that b raised to this power equals n. So if you think of it, b to the x equals n. So then the example I use then becomes log 2 to the third power equals 8. So if I have a whole number, and this is 8, I know this is going to be 3, so my answer is H. I think if you don't just conceptually, and honestly, my concept of logarithms is probably limited. I don't deal with them every day. I would probably just enter this into my calculator, go to the log base feature. I think you do that alpha y equals on your calculator if you have a TI-84, and I would just plug these numbers in to see which one works. The right triangle shown below is 8 squares high and 10 squares long. One of the following values is the ratio of the shaded area to the unshaded area. Okay, so let's go to the unshaded area first. We're going to count these squares. So you count them and you should get 28. So 28 are unshaded. So base times height divided by 2 is equals, our base is 10 and our height is 8 divided by 2. That means our total area is 40. And so all of this triangle, all of it is 40. So 40 minus 28, the white unshaded area that we counted earlier. So 40 minus 28 is 12. Okay, so that's the unshaded. So that means this is 12, right? So 12 to 28 is the ratio, okay, or 12 to 28, because ratios can be expressed as fractions as well. So 12 to 28, and that's going to reduce to what? 12 to 28 reduces to, we divide by 4, so 3, it's a terrible 3 over 7, so A. Let's do this two ways. First, let's do it just straight up exponent math. So maths multiply, add, divide, subtract, powers, multiply. Since we're multiplying, we're adding. So we're going to have 1/4 plus 1/6. We're adding exponents. Well, we have to get common denominators. Well, what's the common denominator? 12. So we have 3 over 12 plus 2 over 12. So now we have x to the 5 over 12. So that becomes, if you know your exponent rules, 12 root x, yeah, 5. So that means the answer would have to be J. Don't be careful with choice H, just has them backwards. Now let's say you wanted to double check that, or if you didn't even know how to do your exponent rules, like, I don't know, what am I doing? Well, the other way you can go about this is just to plug in x equals 2. So if you just plug in x equals 2, let's try that. X equals 2. So you get 2 to the 1/4 power plus, or times 2 to the 1/6 power. You can do that on your calculator. You get 1.19 times 1.13, and that's 1.34. And then you can enter in 2 for each answer. Put them in your calculator again. See what they all equal. Well, this one's a little 4,096. This one's 1.15, 5.27, 1.34. Yay, they match. That's the other way to do this one. So if you know your exponent rules, it's a 30-second question. If you don't know your exponent rules, it's a 45-second question to plug in x. So whichever the fastest way for you to get the correct answer is, that's what you should do. On one day, the New York Currency Exchange, 1 British pound could be exchanged for $2.75 in U.S. currency, and 1 Canadian dollar could be exchanged for 92 cents in U.S. currency. On that day, how much Canadian currency, rounded to the nearest Canadian cent, could be exchanged for 2 pounds? So let's go ahead and say, if 1 pound, so 1 pound, let's see if I can draw this right. There we go. That's close enough, right? 1 pound is 2.75, right, as we see here. So that means that 2 pounds will be, let's just double that, it'll be 5.50. Okay, and so 5.50 for 2 pounds, and then we're going to divide that by 92 cents, right? So 0.92, and that equals 5.98. So your answer is E. The sides of an acute triangle measure 17, 16, and 15 centimeters respectively. To measure the smallest angle of the triangle is a solution for A to which of the following equations? So if you look at these equations, you'll recognize it maybe as the law of cosines. So the law of cosines is c squared equals a squared plus b squared minus 2ab times the cosine of c. And so we're looking at the smallest side, right? Smallest angle is opposite the smallest side. So since we know it's a law of cosines, we can already eliminate choice F and J. And then the smallest side will be 15. That's a terrible circle. Let's try that again. Smallest side is 15. That means the smallest angle, cosine A. So your answer has to be K, right? Because the A, B, and C just represent sides, and we're looking for the smallest side. So that's what we're solving for. This is one that if you know the law of cosines, it's a pretty easy question. And if you don't, it's going to be a tricky question. Set A and set B each contain 5 distinct numbers. The two sets contain identical numbers with the exception of the number with the least value. So they're going to have one number that's different. Let's put that in a different color because that's important. So one number that's different in each set. The number with the least value in set B is greater than the number with the least value in set A. The value of which of the following measures must be greater for set B than set A. So let's go ahead and just pick some numbers to represent set A and B. So I just did 3, 4, 5, and 6, and the numbers are identical for 4 of the numbers, right? So these numbers are identical, but we need a different number for the one with the least value. So since the number for set B is greater than A, I chose 1 for A and 2 for B. Now let's just go through and see which of these has to be true. Which of the following must be greater for set B than set A? The mean only. Well, we know the mean for set B will be greater because 2 is bigger than 1, so that average is going to be slightly bigger. So I think it's probably A. Let's go ahead and circle A to be sure, or to mark it. Median only? No, the median's the same, so no, that's not it. Range, well, the range is actually bigger for set A, 1 to 6 versus 2 to 6. And we know these are out because range only is out. Range is out here as well, so it has to be A. So that's a pretty easy question if you plug in numbers to help you. Of the 16 rental cars on the lot, so there's 16 cars on the lot, 6 are minivans, 7 are sedans, and 3 are hatchbacks. Thalia will rent 3 of these cars chosen at random for business associates. What's the probability that Thalia will rent one of each of the 3 types of cars? Okay, so this is a probability question, and it's a little bit tricky. So we got to say, okay, she could rent a minivan first. Let's say she first rents a minivan, and then she rents a sedan, and then she rents a hatchback. So what are the odds that it happens in that way? So we know there's 16 cars for each one. So probability is what you want over what you have, right? So there's 16 cars for each one. So if it's not going to be 16 total because after you rent one, it's not 16. Okay, so if she rents one car at 16, then she has 15 choices and then 14 choices. So if a minivan, 6 out of 16, and then a sedan, 7 out of 16, and a hatchback, she has a 3 out of 16 chance to rent a hatchback. Now, but it could be a different order than that. So I'm just going to pause and write all the possible orders down. So here's all the possibilities. So you could have a sedan first, then a hatchback, minivan, then hatchback, sedan, sedan, hatchback, minivan. So each of these is a distinct possibility of the order in which it could occur. So what that does is it just changes the order in which the numbers are written too, right? So 6 times 3 times 7. So it's pretty much going to be similar all the way across, but we want to know what are the odds that each one of these will happen. So now what we want to do is multiply straight across, right? 6 16ths times 7 15ths times 3 14ths. And that is going to give us 126 over 3,360. 3,360. I wrote my numbers down on a piece of paper and couldn't tell if I wrote a 3 or an 8. Okay, and that's going to be the same for each of these as we go down. So that is the likelihood that any one of these scenarios happens, right? That you get it in the order of minivan, sedan, hatchback. That's this one, right? Minivan, hatchback, sedan, sedan, hatchback, minivan. So that's the likelihood that each one will happen in this way. What's the probability that she will rent at least one of each car? Well, now you got to add these together. 126 plus 126 plus 126, or you can multiply them times 6, right? So, and that's going to give you 756 over 3,360. And if you use the math frac key and just reduce it on your calculator, it's the fastest way. If not, you just keep dividing, but you get 9 over 40. And 9 over 40 is choice J. Another way you could do this, if you didn't know how to reduce it, you could do 756 divided by 3,360, get that in a decimal form, and just see which one of these is the same decimal. So choice J is the correct answer.